So last time we were here, we had talked about ands. If you had to do an and, it meant, oh, let me pause this for a moment then. Okay, so and or. And means both conditions have to be true, or means either condition can be true. I'm not going to talk too much about this because we've already have, but like if you have this. If A and B, print yay. A and B both have to be true. If A is false or B is false, it's not going to print yay. Usually that, comes in the format of some actual expression, some logical expression that turns into either true or false. Like if temperature is less than 32 or greater than equal to 32 and temperature is less than or equal to 212, print liquid water. Like that. So this condition and this condition have to be true. Now, or, only one or the other. If A or B, print yay. Now, if either one is true, it'll go ahead and go. They don't both have to be true. However, if they're both false, it's not going to trigger. And so you word things like this. If the temperature is less than 32 or the temperature is greater than 212, print not liquid. So as you can see, you can use and to check to see if something is within a range of values, and you use or to see if something is outside of a range of values. And if you get all fancy and start using nots and things like that, you could probably use and, to do one thing or, to do the other. But in its simplest form, you can use and or for those cases. Alrighty. Using or selections for efficiency. I think we talked about this. If you have an and statement, if A and B, print hello. If A is true 90% of the time and B is true 10% of the time, you should reword it. If B and A. Why? Because this one's false most of the time. So it can rule that out. It only checks the first one, and then if that is true, then it keeps checking. So if we can rule it out here, it doesn't even have to do that check. Now in Python, you're not doing the world's most efficient language. But if you go on and, write in C, C++, kind of languages that, Xbox and PlayStation games are written in or whatever, then you are trying to maximize the speed and you do care about things like that. So if A is true 90% of the time and B is true 10% of the time, you should reword it. Let the shortcut for that is put the, okay, how did they word it? Because my brain just froze on this. Put the question less likely to be true first. And by question, we mean expression. Or is the opposite. So that's for and. How about or? So for or, put the question less likely to be true last. So if A or B. Why? Because it checks the first one every time. But if this is true, it skips evaluating the rest, right? Because it already knows the whole expression is true. Because the way the or logic says is, if that one's true, great. If that one's true, great. It's only when this one is false that it has to actually check that one. So you want to put the one that's most often true. I have that backwards. put the question that's most often true first so that it doesn't have to check that secondary case except in a minority of cases. Avoiding common errors. The second question must be a self-contained structure. You just have to get the syntax right. You can't do this even though we did it in grade school. If 32 is less than a temperature which is less than 212. Looks great. Doesn't work. You have to write it like this. If 32 is less than a temperature and the temperature is less than 212. That's the only way to get that to work. Why? Because each one of these is a binary operator. Binary operator means that they take two operands. They take two things on. So this one has to have two things, one on either side. And what if it evaluates to true or false? Great. Either way, it's going to evaluate to some logical value, and then it's going to look at this and go, okay, if true is less than 212. And it's going to go, what the what? It doesn't know what that means. So both the first and the second expression have to be fully expressed. They have to be good expressions. So that has to be true, and that has to be true. So people also do things like this. If A equals 32 or 33. That looks great, right? But that's wrong. Why is that wrong? Same reason. This gets evaluated first, and that gets turned into either true or false, and then it says if true or 33. And that's, again, a what? Can't do that. So if A is equal to 32 or A is equal to 33. That's correct. So the Boolean expressions have to be complete. Make sure to use OR selections when they are required. Make sure the expression is not trivial. Alrighty. Did they give an example of what not trivial means? Yeah, of course not. Well, I'm not going to lecture about it then. I guess it's something that's always true. Why would you put an if statement that was always true? So, all right, the not operator. Not reverses the logic of the Boolean expression. Back when there was the Colbert report, I always said it, reverse the truthiness of it. So if you have this, if A is equal to 32, this means if A is equal to 32. But if you do if not A equals 32, that means if A is not equal to 32. Just reversed it. What does it do? It does that first, and then it flips it. So if A is in fact 32, that evaluates to true, but then not flips it to false. And you can write really complex expressions if you want. If not A is equal to 32 and not B is equal to 34, you don't necessarily have to type this because I'm just trying to make it look horribly complex. All right. That's a valid expression. I don't know what it means. I'm looking at it and my brain breaks when trying to figure out what it means. But you could piece it through if you wanted to and figure out what it worked, but it probably would be better to find a way to rewrite it. And there are some rules for rewriting not expressions. If you have this condition, if not A or B, the way you can rewrite that is if not A and not B. And if you have if not A and B, then you can rewrite that as if not A or not B. So if we wanted to rewrite this, and we wanted to get rid of that not to try to make it simpler? Well, we have that and case there, so this is the rewriting. And this is called De Morgan's law, by the way. It's a logical law. Logic meaning, you know, true, false, not anything else. Okay, so what's it called when you have something like this? X is equal to 3, 2 plus 4, and you rewrite that to say x is equal to 3 times 2 plus 3 times 4. Is that the distributive property or something like that? This is kind of the same, except notice that the symbol flips. It goes from and to or to and. So anyways, we're going to rewrite this. We're going to take that not and put it inside these things. So, but it's going to look silly if not A is equal to 32 and not B is equal to 24. Well, what does not mean? It doesn't mean anything. One logically flips it to false, and then the other flips it back to true. So you would just rewrite that if A is equal to 32 and B. I made a goof, though. If that was supposed to be an and, then when I rewrote it using De Morgan's law, I should have changed it to an or. My apologies. Alrighty. So if A is equal to 32 or B is equal to 24. There, that's the same. I'm going to put a comment up here that these are De Morgan's law. Now, do I care if you can rewrite that expression? Not really. Yeah, I'm not demanding that you burn De Morgan's law into your brain. I doubt I'll even ask it on the exam. But just know that if you wind up typing something like that, the computer likes it, and the computer loves it. It'll run it great. But a human trying to figure out what it means or how to modify it or understand what it means is not going to be able to understand it. And if you can rewrite a complex expression into a simpler one, that's a good idea. Another way we could rewrite this is that we could store the results in temporary variables. Something like this. A is equal to, or excuse me, X is equal to, A is equal to 32. This evaluates either to true or false, and it stores it into X. And then you could do Y is equal to, B is equal to 24. You see where I'm getting these, right? That's X is equal to 32. A is 32, B is 24. And I know that some people's eyes are starting to roll up in their head. Then you could write if not X and not Y. It's starting to get better. Then if you remember De Morgan's law, you could make it a lot better still. And it would look like this. If X or Y. You know, that's way better. You know, to do temporary variables and then base your expression. What do I mean way better? If I had to understand that, my brain would break. If I looked at this, I go, oh yeah, I see what it's doing. So to sum up, write expressions for clarity. You can break them up into multiple lines by using Boolean variables, which are also known as flags. So that's a flag. That flag is set to true if A is in fact equal to that value. That's also a flag. Y is set to true if in fact B equals that value. And then you can make an if statement based on those flags. All right, here we go. Be careful not to create trivial expressions. Incorrect code. If not or not, then output that. Oh, whatever. Here they're using the inverse of the distributive property to put not out here. And to me it looks like they got it wrong because De Morgan's law would say that we needed to. Anyways, I'm not going to mess with that. If I told you De Morgan's law wrong, then I got part of my lecture wrong, and I'll revise it. You get the idea, though. You write the simpler statements. This one is easier to understand than this one. And I did give you De Morgan's law wrong. So I'm going to come back up here, and if you were taking notes, I'm going to put distributive property instead of De Morgan's law, I'm going to change this line where we flip from or to and. I'm going to make that or. And I'm going to change this line where we flip from and to or back to and. And you can see how these are similar. Which means I have to fix that line, change the and on the following. And so that would leave that also as an and. After a certain point, I needed to just use all ands all the way through once I got past that part of distributive property. And I'm sorry to switch gears on you like that. That means I have to lecture on it again, unfortunately. So plan on sleeping for 5 minutes the next lecture. Just kidding. Alrighty, making selections within ranges. 10 or fewer, 11 to 24, 25 to 50, 51 or more. Let's use our own example though. So if you're under 5, so 5 and under is kindergarten. 6 to 12 is grade school. 13 to 15, and I don't know if these are right, but whatever, they vary based on, how close your birthday is to the cutoff point or whatever. Middle school or junior high. And then 16 and up, high school. Say we have those ranges. That's fairly close to their example, right? So let's write some code that prints these messages based on these age ranges. If age is less than or equal to 5, right? Because it's 5 and under. It has to include 5, so we could not make it age less than 5, right? Because then the 5-year-olds wouldn't be in kindergarten. You just have to look at it carefully and make sure that you're including the boundary that is specified. Boundary is here, so yes, we're going to do that. So if that's true, we're going to print kindergarten. And I could be using else's in here. I'm not going to at this point. So how we do this? Age has to be, is this correct? Age greater than 6? Or should it be age greater than or equal to 6 to do that second range? It has to be greater than or equal. Why? So that we actually include 6. You got to figure out where the boundary condition is. Because what if they were 6 years old, but they hit this if statement, it would not print grade school because it would only allow 7-year-olds into grade school. So if age is greater than 6 and age is, no, it needs to be greater than or equal to. And again, we want to go up to and including 12. Another way of wording that would be saying less than 13. But I'm going to make it equal to because that expresses the range. All right, the next one's pretty easy, right? Just the same way, 13 to 15. If age is greater than or equal to 13 and age is less than or equal to 15, print middle school. When did they start calling it middle school anyways? And then, used to be junior high. If age is, am I going to make it greater than 16 or greater than or equal to 16 to abide by that logic? Who thinks greater than? Who thinks greater than or equal to? Okay, one person actually raised their hand. The rest of y'all don't care or don't understand. I have some sympathy, but I could flip around and give you this to y'all as a quiz on Wednesday, so I hope you're actually getting it. That's one way to word it. Another, if you didn't want to use greater than or equal to's or less than or equal to's, if you only wanted to use, greater than or less than, you could rewrite it. If you just want to use less than, are you going to check for 5? No, you would check for 6. If age is less than 6, you're going to kindergarten. And then, if age is greater, this is kind of stupid, greater than 5 and less than 13. Okay, so I'm getting kind of disenchanted because these numbers and these numbers aren't matching at all, even though it's logically correct. I'm just going to abort, fail. But you can use what's known as Elif or Elseif in other languages to shorten this logic down. Here's what it would look like with Elifs. If age is less than or equal to 5, do kindergarten. Elif, age is less than or equal to 12, go to grade school. Elif, age is less than or equal to 15, go to middle school. Elif, nope, we don't even need an Elif. Else, high school. These mean the same thing. Logically, these are identical. I think this is easy to read. So if you plug into your brain that you can shorten these expressions, why did I have to do it this way? Because without Elif, I had to express both ends of the range. But with the elses, with the Elifs, I could just check the higher end of the range, right? Because if they're not less than 5, it would skip down to this. And then, okay, yeah, we are less than 12. We're going to print grade school, and then we're going to skip all the rest of the Elifs. All the ends, we're just going to go down to the beginning. That's what this means. These, when you start using else's, it makes it mutually exclusive. If that's true, great. It skips all the rest of them and goes down here. If that's true, great. It skips the following ones and goes down to there. If that one's true, well, great. At least it skips that one. And if none of these were true, it finally does that one. So if you were going to flowchart this, wish I had the flowchart already drawn. Looks like I'm not going to have anything for y'all to upload today. So, all right, so I want to do a flowchart for that if and then if else. And hopefully you'll see the logic of it. It's annoying, though, the way that we're going to have to flowchart it. Show you what I mean. I should just draw it on the board, but I never trust the... I'll do that faster. Trust the markers will work. Let's be optimistic. All right, so the first one is just a series of ifs without elses. So it looks like this, because we remember what an if without an else is, right? It goes over here and it does something, and then it comes back. Right? And then if the next one's true, it does something, and then it comes back. If I was going to be fancy, you know, I'd put little connectors. And then a third one, it checks it, and then it comes back. And I've hit the end of my, you know, I only had room for 3 ifs because I started too low. But anyways, so if age less than 5, great, do kindergarten. And I did the wrong shape. Since I'm doing printing, they should be tilted rectangles. And this one should be age greater than or equal to 6 and age less than or equal to 12. And print grade school. And then we had one more. If age was greater than or equal to 12, and age is equal to whatever, then print out, middle school. This represents the first one. Since we're not using any else's, it's just all in sequence, right? It's a tower of decisions. But this one has else's, and we know what an else looks like. It juts off one way and then the other. Hope this makes sense. Anybody drawing this on, need to leave it on the screen. Nah, all right. So these are sequential ifs. We're going to do some if-else's now. Different kind of logic. This code sure looks better on screen, but when we draw a flow chart, it looks kind of like this. What's the first one? If age is less than 5, then great, we print something. We print kindergarten. But if that's false, true, false, yes, no, whatever, then we go over here and we do something else. And then we check to see if age is less than equal to 12. And if that's true, we print something. We print, grade school. Else, what's our else? We have another if statement. See why this is getting annoying? At least it's annoying to me. I should give value judgments like that. You may think it's the best thing since cream pie. Alrighty. Else if age is equal to 15, then yeah, print, middle school. And now we have the problem that they all have to connect back up because you're not allowed, any dead ends. So we have a connector here. We have a connector here. And we have a connector. I did that one wrong. Yeah, that one should have gone there. And then, anyways, okay. Looks kind of lousy, but there. This is a correct mapping of this, except for the fact that I only did 3 decisions rather than 4. First one's easier to draw, isn't it? In my mind, it is. But this one expresses what it is. If something is that, then do that. Else, if that one, do that one. Else, if that one, do that one. And you could shift the placement of these. You know how it doesn't really matter as long as the arrows are going the right way, whether things are going left or right or right or left. You could take these if statements and push them over here, and it would look kind of like a stack of ifs. But logically, it's not a stack of ifs. This is a stack of ifs. This is a cascade. This term of it, an if cascade. Why is it a cascade? Because a cascade is like a waterfall, like that. Alrighty. Onward and upward. And they're showing an if cascade here to solve this. Right? Here's their items order, give you a 0% discount. 11 to 24 items is 10, 25 to 50 is 15, 51 is 20. So they cooked up a cascade. Is items less than range 1? Well, see, they even use some constants here to make it all nice. And that would have been a better way to do it. Why are constants better? Because then you put them all up in one block, a block of declarations up way at the top. So if this is true, then you're going to print they get discount 1. But it's not true. So you come back over here. If that's true, you get discount 2. If not, no, we have another if statement. All right, is it part of range 3? Yeah, then print out discount 3. Else it's discount 4, and then they all have to hook back up together. And then they show some code. Notice that their if looked different than mine because some languages support this syntax of using else if. Technically, we could get away with that if we put colons after the words else or whatever. But usually in Python, you just do elif, and then you don't have to worry about tabbing it over so much, right? Maybe you can see the difference between their example and my example. Yeah, this is too small, but I like this way of doing it. Fewer indentions. Don't have to keep track of so many indentions. So I like the Python word Elif. So, avoid a dead or unreachable path. Don't bother checking for values that can never occur. Never ask a question if there's only one possible outcome. That makes sense. Are you alive or dead? I'm alive. You know, if somebody's typing it, they're not dead. Whatever. That's a stupid example. I can't think of one where you would ask for a question if there was only one possible outcome. Avoid testing the same range multiple times. Makes sense, right? You know, if you're going to check to see if the temperature is less than 32, you don't need another if temperature is less than 32. Eliminating dead paths. I'm just going to trust that. Well, I guess we'll look at it. All right, this is a dead path because if the items ordered is not greater than range 3, nothing happens. So why do we even write it like that? We could have just said if items ordered is less than range 3, then they get the 4th discount. You know what, I don't really care about that. I don't see anything fundamentally wrong with that. Avoid testing the same range limit multiple times. Here they are doing what we did on our first statement, right? They're checking both ranges. Oh, come on. Right, they do an if here. If that's not true, they check range 1 again and range 2. Else, they check range 2 and range 3. You don't have to do that. You check range 1. If that's not true, then you check range 2. If that's not true, then you check range 3. So you don't need to write it like that. If you're going to write it like that, then you're not going to bother using else. Understanding precedence. Just like math symbols have precedence, the logical ones do as well. So and is evaluated first. Just like our PEMDAS, you just have to remember that ands are evaluated before or. And I can give you a little truth table that shows you why. Remember how we did this one, A, B, and then the result. And if that was false and that one was false, then your result was false if you were doing an and. And if that one was, this would be the last thing we do, if that one was false and that one is true, they're and, right? So what is the result going to be? And means both have to be true, but only B is true, so is this true or false? Yeah, it's false. Same thing there. Alrighty. I think I did this example. Then if we're going to do ors, very similar. Or if you have two falses, it's obviously a false, but or means only one, if one or the other is true. So once one of them turns true, these are called truth tables. This is a truth table for and. This is a truth table for or. And if you look at it, this actually kind of looks like multiplication, right? 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is 1. So, and can be treated like multiplication. But look at this. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1, well, this is a world where we only have two numerical values, true and false, 0 and 1. So 1 plus 1, we're going to call this 1. So or can be treated like addition. And if you think back to PEMDAS, multiplication happened before addition. So ands have higher precedence than ors. And we're not going to do any examples of that because we're just about out of time. All right, any questions? If we need to hang out and talk about homework, let's do it. Otherwise, I'll see you on Wednesday. Oh, by the way, I'm going to have to take the 9th off for something I cannot avoid. That means you get the 9th off as well. I'll post about it again. April 9th, we're not going to have class. I'll post a notice to that effect. I'll email it, and then, I'll text it out like on Sunday, Make absolutely sure nobody shows up.
Have a mistake.
You too.
Question.
Yeah.
I'm still trying to figure out MindTap. Was there a MindTap chapter 3 test?
It's there, and let's look to see if
It
it's
ended.
got a link. Oh, if it's ended, I need to fix that. My mistake.
Okay.
All right, for those of y'all still here, if the MindTap 3 exam has ended, I'm opening it back up. My apologies, I did not.
Okay, because it's scaring me because I got a big fat 0.
Right, you got a 0 on it. No, I'll open it up.
Well, and then I also looked, and there's a whole bunch of assignments in MindTap because I know we're doing
There
this like
are,
50,
but they're
50.
not required.
Okay, because I was like, I have like 20 missing assignments and I got a 0 on a test. I'm freaking out because
Yeah,
I think I'm going to
that
fail
looks
this
bad, but
class.
the examples are all, all
you
the other
say MindTap
assignments are
is-
optional.
The MindTap percentage at the end of the year is going to affect our.
It will.
overall
It'll be counted, as quiz.
Because right
It's like
now
20.
I think I have a 60.
Don't worry about it. Take the next exam. The only ones that count are the ones that call test. If you want to do the other assignments, great, but they're not going to
Oh,
be.
well, they're for
good
Java
for
and C++
Yeah,
and
yeah.
stuff like that. And I was like,
If you feel ambitious, I'm
I
going
was-
to do
I didn't know
Java,
if you wanted
but
us
you
to-
don't have time. So, yeah.
Okay. Oh, thank you.
Sure. Yeah, absolutely. I'll be right back there.
So you already opened up, so I'm gonna take it.